Section 8.3, example 5, graphing a parabola from an equation given in general form. Graph the parabola below, identify and label the vertex, axis of symmetry, focus, directrix, and endpoints of the lattice rectum. So basically everything we have done so far, just mixing in some of this stuff here. All right, so looking at this, I see that we have x squared. So everything with the x, we're going to put on one side. Everything else, we're going to put on on the opposite side. So let's add 28y to both sides. Let's add 208 to both sides. So what we have here, let's get into our working color. X squared minus 8x. Since I know that we're going to have to eventually complete the square, let's leave a little space there. And over here we have 28y plus 208. All right, kind of looks good so far. Let's complete the square on the left side so that way we kind of get a little bit closer. So half of b squared, half of 8 squared, -4 squared, which is 16. So adding 16 to both sides. And what we did on the left side is we made it a perfect square. So we have x minus 4 squared on the left side. Over here we have 28y plus 2, 4 on the right side. Right? Let's do this. 208 plus 16, 224. Okay, so now let's factor out a 28 from the right side. X minus 4 squared is equal to, factoring out a 28, it's going to leave us with y plus 224 divided by 28. Perfect, 8. Scared me a little bit, but it's okay. And lastly, to get it in our proper form, let's factor out 4 so we could figure out what p is. X minus 4 squared is equal to 4 times p. So we have our 28 divided by 4. That's 7, y plus 8. All right, looks good. So now from here, we could find everything that they want us to find. So that being the vertex, the axis of symmetry, the focus, directrix, and the endpoints that make up the lattice rectum. All right, starting off with the vertex, we could get the vertex just by staring at it. So our shift in our y component, so that's going to be 4, and shift in our x component, that's going to be a -8. I think I said x, I meant y. And now axis of symmetry. So let's look at this. X being the one that's squared tells us that we're going to have either an upward facing parabola or a downward facing parabola. Since p is positive, we're opening up in the positive direction, so an upward facing parabola. Upward facing parabola tells us that we have axis of symmetry coming right here through our vertex, our x component of our vertex. So we have x equals 4. Now for the focus, we're going 7 units in the positive direction. So 7 units up. So we're adding 7 to our vertex. So 4 comma -8 plus 7 is going to be a -1. Directrix. Directrix is going to be y equals, and from here we're shifting down So subtracting P from our Y component of our vertex. So Y equals subtracting P from our Y component of our vertex. So Y equals -15. Now we have our focus, we have the directrix. Latus rectum goes off of our focus. So moving left 2p units and right 2p units. So that tells us that we're moving our x component. So our y is what doesn't change. So from the focus, we go out -1. That doesn't change. P is 7. Cool. So 2p is going to be 14. So from our focus, we're subtracting 14 and adding 14. So 4 minus 14 is going to be a -10. And then 4 plus 14 is going to be 18. All right, let's graph all of this and see what we end up with. And then we'll graph it on Desmos just to see what it looks like. But starting off with, oh man, this is going to be kind of ugly. All the way down here. We don't have much going on up here, so we'll bring it kind of high. All right, so vertex at 4, -8. Let's do this. So 4, we have 1, 2, 3, 4, -8. 1, 2, 3, 4, 5, 6, 7, 8. There's that. We have our axis of symmetry here at x equals 4. So axis of symmetry, x equals 4. And next we have a focus at 4, -1. So 4, -1. And we have a directrix at y equals -15. So that's -8, 9, 10, 11, 12, 13, 14, and 15. So we have this line right here. So this is our y equals -15. And this is our directrix. Latus rectum coming down, left -18. There we go. Or -10. So 1, 2. Gonna need a little bit more space. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So -10. Going down -1 unit. That's going to be right here. And going across 18 units. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. Down 1 unit. And this is a pretty big scale. But there we go. And as promised, let's graph it on Desmos. Just a second. All right. So let's start by graphing all of our components. Let's start with the vertex. We have 4, -8. We have axis of symmetry, x equals 4. We have a focus at 4, -1. A directrix at y equals a -15. We have lattice rectum at -10, comma, -1. And another point that make up a lattice rectum, 18 and -1. All right, looks good. And now final thing that we want to graph, let's graph our parabola. So x minus 4 squared equals 4 times 7 and a y plus 8. Wow, so pretty. But even cooler, let's see what the original function over here was. See if we got it right. X squared minus 8x minus 28y minus 208 equals 0. And look at that. Everything aligns on nicely and perfectly. There we go. We have our focus right here. We have our directrix, the points that make up our lattice rectum right there. And of course, the main part, the vertex. But it's beautiful. And I understand that not everyone finds it that beautiful, but it's okay. Hopefully you do. If you do have any questions, please feel free to ask. Please don't hesitate. Ask away. But if not, I'll see you guys later. Bye.